Okay, so to give you a glimpse about Cisco, Cisco is a Fortune 55 company. And if you take the annual revenue, it's more than 55 billion US dollars. And if you look at the nature of our business, we are into food distribution. We distribute food to restaurants, schools, hospitals, and hotels. Now, if you take our Cisco e-commerce platform, which is known as the Cisco Shop, the annual the transactions that go through our Cisco Shop per week is more than 1 billion US dollars. So this Cisco Shop, it caters the web and the mobile application. And considerable amount of these transactions goes through our mobile platform. So because of that, testing the mobile application, if you look at it from the business point of view, it's very important for us. Now, when it comes to mobile testing, there are lots of challenges. But for us, the main challenge was fragmentation. Because we need to test our mobile application on Android platform. So when it comes to Android, we have different operating systems. Manufacturers, so we need to test it on Samsung, HTC, Motorola. Mobile phones, tablets. So when it comes to iPhone, iPads, mobile phones. And also, our test teams are geographically located in different parts of the world. So we have 2 offices in US, one in Austin and the other one in Houston. We have testers in India, and also we have testers based in here in Colombo. Now the testers who are based here in Colombo, like we had limited number of mobile devices. So we had all the latest, coolest devices in US, we had all the coolest devices in Houston and Austin, but for the testers based in India and Colombo, we were unable to access those devices. Now we have release deadlines, loads of testing, but we don't have sufficient devices to test it. Now as a result of that, we came across unhappy testers. Now this is purely because you are unable to get a mobile device to do your testing. The moment you are unable to access a device, you go mad. And that moment, we thought that we are going to build our mad lab. My dear friends, I'm Kishan Navaratne, Senior Quality Engineering Lead at Cisco Labs. So the next 15 minutes, I will take you through a journey. How did we build our mad lab? So this mad lab is Mobile Automation Device Lab. So now when it comes to Mobile Automation Device Lab, our approach was whether we are going to go ahead with cloud-based solutions or are we going to build it from the scratch as an on-premise solution. So rather than reinventing the wheel, we thought, okay, first let's evaluate the cloud-based solutions. So we evaluated Perfecto Mobile, which is supposed to be the world's leading cloud-based mobile device platform. We evaluated that. It's really good. It supports our test framework. We were able to run our test on Perfecto Mobile. Execution speed is really good. But there were a few limitations. Real-time monitoring, those were some kind of limitations. But when you compare the cost, for 20 hours, Perfecto Mobile, the charges are for 20 hours, it's $299 US. If you want to use Perfecto Mobile for 20 hours, the price will be $299 US. So we thought of, we'll evaluate Source Lab. But when you compare Source Labs with Perfecto Mobile, the execution is very slow. But you will get access for the latest, coolest device, but still, you will not get a dedicated device. And also, when it comes to pricing, Source Labs, for 8 concurrent devices, the cost for a month is going to be $1,200 US. For 8 concurrent devices for a month, the cost is going to be $1,200 US. So we thought, let's evaluate the AWS device farm. Now, when you compare AWS device farm with Source Labs and Perfecto Mobile, the execution is really, really slow. And also, like we noted that our test framework is unable to execute some of the tests in AWS device farm because AWS device farm does not support most of the test NG annotations, like before class, after class, before method, after method. Those are not being actually, you can't execute them through the AWS device farm. And also, you will not get real-time monitoring. So you will be able to get a video, the screenshots, and all those things after the test execution. So we thought, okay, are we going to go ahead with Perfecto Mobile or Source Labs? But then when we evaluated this for a 3-year plan, we realized that for us to go ahead with a commercial-based tool, it costs more than $0.5 million US. More than $0.5 million US. So the next option was to think about, are we going to build it from the scratch? Now, actually we had few devices. We had few devices in Colombo, we had several devices in Houston, we had many devices in Austin. So what we thought was, we came up with a very simple approach. So this was our basic idea. We have offices in Houston, Austin, in Colombo. What we did was, we took a server and we connected all our mobile devices. And we thought like, okay, so we were able to get this mobile UD ID and we configured it in our Jenkins job. And we thought, okay, once we execute our Jenkins build, we should be able to run our test against the mobile device. So this was our basic approach. But there were few limitations. With our basic approach, we were unable to find out what are the devices connected, what are the devices disconnected. So let's assume that there's a Scrum team executing your test and another team is trying to execute your test, and at the end it jams and your execution fails and you don't get a good result. That is because we don't know whether these devices is now actually a test is executing. So those kind of information we were unable to get. And the other thing was, we couldn't do real-time monitoring. So you can run your test in a machine based in US, in a mobile phone based in US, but you are unable to go and see what's happening there. That was another limitation for us. And the biggest limitation was for us to do remote debugging. So when it comes to debugging, we were unable to do it. So with our basic approach, we came across these issues. So what we did was, we thought now we need to find a solution. And when we searched, we were lucky, there was an open source solution which catered all these issues. And we were able to find an open source tool called OpenSTF, Open smartphone testing farm. So this tool, it had the capability to check whether the devices are connected, disconnected, and you can do remote debugging, remote monitoring, all those features it supported. But there was a small problem. This OpenSTF supports only the Android platform. Now in our business, for us, testing the iPhone platform is also very important. So what we did was, because of this limitation, we had to think in a different way. So what we did was, we took the WebDriver agent, we customized it, we configured the WebDriver agent ports, and we deployed it in our iOS mobile. So with that, we were able to access remotely the iPhone device. So with that, we were able to call it through our OpenSTF platform, and we were able to execute our test on iOS platform. So now, in our basic MATLAB, we are able to execute test on Android platform and also on iOS platform. Okay, so we'll go into a demo and see how we have actually built this MATLAB. So Sandeep, who is a senior quality engineer at Sysco LABS, so he will take you through a journey how we have built this MATLAB. Over to you, Sandeep.
Good evening, friends. So first of all, as Kishan said, this is our MATLAB, and I will be taking you through the journey of the MATLAB and the problems we came across and how we executed those problems. I mean, like how we solved. So we had a problem, as Kishan said. We had a problem with CI/CD job execution because of the invisible devices. By invisible, I mean not knowing the connectivity of the devices with the Jenkins agent. So in Jenkins we can find out what are the connected agents with the Jenkins server, but you don't know what are the connected devices to a particular agent, right? So we had that problem. And apart from that, we had another problem. We didn't know what's happening on the UI, the real device, because some of the devices are in remote locations, not next to me. So that was another problem. Then another problem was we couldn't find what are the related information, the OS of the Android devices, the iPhone devices, or anything. We couldn't find them. So we had a thought of going back, and we came across with this. This is one of the issues we got. So this is because I have given an unconnected or the detached device UDID with my Jenkins job, and I got failed in this job. Because of this run, we thought of why can't we find out the way to grab whatever the information on the device? So then we were lucky. We had a lookout on the solution for some solution like that, and we found the OpenSTF. So OpenSTF is a solution written in JavaScript. So you can get it from the npm install STF, or else you can fork from the original repository, then add your flavor. So that's up to you. So in OpenSTF, we were able to find out, we were able to solve most of the problems, and we got some bonus as well, I'll tell you. So we were able to find out what are the information on the device, the attached devices, and UDIDs and everything, and OSs, everything. And we have the real-time monitoring. So it's like whatever happening on the device is being reflected on your browser, the OpenSTF. And two-way interaction. So the gesture you do on the device screen is getting reflected on the browser. And in the browser itself, whatever you do in the browser is getting reflected on your device. So that's a cool feature. So then we had other features some of the features connectivity, battery issues, everything. And we got a bonus. So that was deploying the APKs remotely. So it was kind of amazing. So using all those features, we were fine with the Android. So let me go with one demo. So basically, I don't want this to happen to my build. So what I'm going to do now is I'm going to fetch one of the connected devices, the UDIDs, and I'm going to fetch it to my Jenkins. So like this is the OpenSTF. So I'll have taken the UDID, and I'm going to feed it in my Jenkins, the job, and the OS as well. Okay, now I'm taking the OS version, and I'm going to let my build execute. So this is totally platform independent. You can do it on any platform. So now the code is being checking out. So it's like, let's say situation like you are in here, and you are going to execute some build on a remote location, on a remote device. So in old school way, you might have to add the console.logs or the system.out.println to see where you are. But with this solution, now you can see what's happening on the device in real time. So let me wait until you see. Okay, now the browser is being up. And on this demo, I'll be going to the automationpractice.com, which is an e-commerce site for practice your automation. So I'll be purchasing 2 of the dresses, and I'll be proceeding to the checkout cart. So whatever happening on the device is being reflected on the monitor. Now you see it. So I said like we got a bonus. So that's the remote APK deployment. So it's basically like you can drag and drop your APK, and you can select your device. So it doesn't matter where it is, the geographical location, it doesn't matter anymore. So you can deploy it on your real device, and you can start testing. For a manual tester, it's like amazing, right? You don't have a device, physical access to a device, but you have it somewhere else, in another office. So what you can do is, you can go to your MATLAB, if you have configured this one, then you can drag and drop, start testing. That's simple like this. And on the nowadays platform, context, we have like several Android devices and the iOS devices. So most of them have the clear big screen, and some of them might have the notches. So as a QA engineer, you can't go back with the notch, right? Let's say you only have devices with the big flat screen. Let's call it infinite display, seamless display, bezel-less display, whatever you call it. You cannot turn your back, right? Because at the end, you are going to production. So then somewhere else in your office, you have a notch device. You don't have access to that. Let's say a remote location. In our example, we take Austin, right? So what I can do now is, when I execute my build on a device like that with a notch, I get my build failed because some of the elements might have been covered by the notch. Not sure, right? Could happen. So what I can do now is, I'll be going to the MATLAB we have created. So it's like bird's eye perspective. You see whatever happening from the above. So you'll be going to that one, and you can deploy your application, or else you can start the browser, because the two-way communication is there. Then you can find out what's happening, what are the elements covered with the notch, or what are the elements not being loaded with the notch, anything. Or else in application, sometimes the navigation, top navigation is there, but you don't see the application name because it's covered with the notch. So that could be like a low bug, maybe. So that can be happen, right? So now we are seeing the demonstration in this one. So the real-time communication is there. And this is like, I'll tell you, wait. Okay, now the execution has been done. But this was a perfect solution for us. Also, it got some faults within itself. I mean, it's like limitations. Because this only supports for Android devices, and you need to have the cable connectivity and a real device, because this simulates the actions happening on the real device with your browser. So those are the limitations. So we had a kind of lookout for the iOS platform to cater the same features to the iOS platform. Then we couldn't find a way. Then we thought of like, why not we use the WebDriver agent for this one? So we thought of using the WebDriver agent, the same WebDriver agent we use for Appium execution, to cater the same facilities. Okay, we will succeed. We were above that one, right? But, you know, like when we deploy a WebDriver agent to a particular device, iOS device, it works fine. But the real-time monitoring doesn't mean whatever I do on my device is getting reflected on this one, because I need to monitor what's happened to my test cases, right? That's the basic idea, because this could be happen to anyone. So we thought of, like this should be tested. So we had a test, and at the same time we tried to monitor the device. We were failed because we are talking about a particular WebDrive agent. The default WebDrive agent takes up the port 8100, and port was crashed because we are trying to generate two agents. So then we thought of like, yeah, we had some researches on that. So we changed the port to facilitate our scenarios and the capabilities. Then we found a way, yes, that supports. So then we changed our ports to take up a random port within the given range of the ports. Then we were able to come up with a real-time solution for the iOS. Then we had this problem, accessing the physical buttons. From the devices, like for most of the devices, we have the physical buttons, volume up, volume down, and home. But still, we can use the accessibility access. Okay, so that was like one solution. But it's not fancy, right? Because being the QA engineers, being the engineers, we cannot go click on that one and click on the home to navigate to home. We cannot do that. So we thought of like, why can't we build this one? If we build the WebDrive agent, why can't we do this? So then we thought of like, okay, let's do. Then we found ways. We did some little researches on this. So we configured some sockets to cater this one, and we found a way to have the WebDrive agent to cater this facility. So now we are seeing the demonstration of the device with the iOS. So the gestures I'm doing on the device is getting reflected on the web browser as well. So I'm going to be typing one message. All right, so now the messaging is enough, so let me go to another application. Okay, now we are saying I have clicked the home button. Then let me take you to the Safari and go through some sites. Okay, so those were two applications we did for the demo, for the iMessage and the Safari. Now you can say those are two native applications for the iOS devices, but still we have tested for the other applications as well, WhatsApp and everything. So for the third-party applications also, this works. And there is no clashing between the ports and the sockets. So this was our solution to find a way to care our facilities and to eliminate some of the challenges. So using this one, we have built our own Mad Lab. At Sysco Lab, we call it Sysco Q Lab.
Thanks, Sandeep. So earlier, I mentioned that we had unhappy testers because, like, the testers were unable to access the mobile devices, they were unable to share those devices. But with this smart approach, using open source technologies, we were able to make our testers happy. So with the Mad Lab, we were able to make our testers happy. And also at Sysco, we have a quality engineering platform team. So this team does a lot of R&D work, and they actually, last year, they did a lot of innovation using open source technologies. And they have saved a lot to Sysco. So this Mad Lab is one of their R&D work. And like, if you take, like, Sysco was earlier using load runner to do performance testing, but this team was able to do R&D, and they were able to find open source solutions to overcome that, and they have saved more than about $1 million on that. So to recognize their hard effort, so at Sysco Labs year-end party, so we have this Hall of Fame award, which is a technology award, and this team won the first runner-up. Yeah, so with that, we will wind up the session, and we can answer the questions during the panel discussion. Thank you very much.